So what I want you guys to do in GeoGebra is to measure all three sides of your triangle. So you go to this little tab up here. I guess if you have other computers, the menus appear over here. Yes? No? With those three bars if you have a Macintosh, I think. But if you go over here, distance length. And all you have to do is click on this, click on this, click on this. Okay, 6, 7, 7. Yes? Hello? Everyone measured your things, and if you drag your triangle around, those measurements will change, right? Isn't that cool? I love this. All right. There's probably a way to get those measurements to be more colorful, or you can move them outside. Can you move them? Can you move them outside the line so they're easier to see? Can I move? Oh, look at that. That's even better. Then do they move along with the triangle? Yeah, look at that. That's great. All right. So now what I want you to try to do is add up the two sides that are these two sides. Okay. So add 7 plus 12. But the way you have to do that, if you remember, you go up here to, where do we go? View, algebra, and then you have to go view, there's input bar down here. And down here, I just want you to click on, how can I do that? A, B, oh, you have to put parentheses, okay? So let's see, parentheses, there's parentheses. So how do I click on AB? How do I find segment AB? How do I put it in there? AB? AB. Won't let me do that. What if I go here? Maybe I could do this. Let me try something else. Text, checkbox, okay. Input box. Well, let me put things in here. Linked object. A is, oh, maybe this will work. Okay. I just want to try something. AB, I should have looked at this. Segment C. C plus, it's not working. I'm trying to add those three up. Oh well, I'm not going to add up those three. We'll wait. But cancel. So if I drag this thing over here, if you guys could figure out how to add those segments, you're better than me. But what's always got to be true about this side plus this side? If I stretch and drag this triangle, okay, as much as I want, what's always got to be true about the sum of AB plus BC? Could it be equal to AC? Could it be equal to, what happens if I make it equal to AC? Do I have a triangle anymore? No. So what has to be true about the sum of AB plus BC? It's always got to be bigger than AC. You get that, right? The sum of AB plus BC has to be greater, AB plus BC always has to be bigger than this. Does this plus this have to be bigger than, does 8 plus 13 always have to be bigger than 7? It does, right? Because, right, you can think about it, the distance between, what's the fastest way to get from point A to point B? What's the fastest way to go to straight line? I wouldn't go this way, right? That takes longer, right? And so the fastest distance, like I could, even if I go straight here to here, still from here to here, this 2 is over here, right? It's going to be, this says it's 7. How could that be, how could it be 7 from here to here? That's because because it's rounding, right? Now it's 8, okay? So the distance from between the shortest distance between 2 points is always along the straight line, so you don't go this way. So that leads to the next thing, which is called the triangle inequality. I'm going to give you a conjecture sheet right here. 1, 2, 3, 4. We'll play with this some more, with some more interesting ones in a second. I didn't figure out how to add those segments together. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2. So we already filled in C17 when we did that exploration, right? Let me bring this up for the viewers in my viewing audience. Geometry Advanced, Chapter 4 conjectures. So let's go through and fill in some of these conjectures real quick. Maybe that wasn't the best exploration in the world, but we'll get there. So C17 said, triangle sum conjecture. The sum of the measures angle is what? 180, right? 180 degrees. Isosceles, these are the ones we did earlier. If a triangle is isosceles, then its base angles are congruent. We'll call it congruent. Better than equal. Okay. Converse of the isosceles, if the triangle has two congruent angles, then it is isosceles. Okay. That's that one right there. Isosceles. Now this one is what we're talking about right now. Okay. So triangle inequality C20 is what we're kind of exploring with GeoGebra. The sum of the lengths of a triangle, the sum of the lengths of any two sides of a triangle is always greater than, okay? Is greater than the length of the third side, okay? So if you have a triangle, let me just draw a quick picture of it now. Let's do it with my straight line tool. Tools, freehand shape. Here's a triangle. Triangle. Okay? So if I have A, B, and C. So a lot of times what they'll do is, when you label triangles, they'll call the side opposite angle A, little a, the side opposite angle B, little b, and the side opposite angle C, little c. So A plus B has to be greater than C. Furthermore, B plus C has to be greater than A, right? And A plus C has to be greater than B. Now watch. You can solve, A plus B has to be great. You can solve these inequalities, okay, for different variables. Some of you did this in algebra, but if I subtract B from both sides of this equation, I get that A has got to be greater than C minus what? B. C minus B, right? And if I subtract B, or if I subtract C from both equations, I get that B has got to be greater than what? A minus C. And if I subtract A from both equations, I get that C has got to be greater than what? B minus A. Do you guys understand what I just did? I did some algebra there. Okay? Now what does that mean? That means that if I have this side and this side, the difference, this side over here has always got to be greater than the difference between them, okay? Physically, kind of what that means, like say I'm trying to make a triangle, right? I have one piece like this, and I have another piece like this. If I want to make a triangle, how long does this third piece, say this is 10, right? And this is 7. How long does this side have to be at least to make a triangle? it has to be at least bigger than the difference, right? Right? It has to be at least bigger than 3, right? Because if it's 3, it's just going to make a straight line, yeah? But if it's less than 3, it's not going to reach, right? If it were like 2, it wouldn't connect. It'd be like the drawbridge. You know the drawbridge? You know what a drawbridge is?
Yeah.
You do? I grew up in New York, and we had drawbridges. And I used to go, who doesn't know what a drawbridge is? It's a bridge that goes like this to let the ships through, you know, and stuff. And then it comes out. It's really fun to try to jump on your car. No, I'm just kidding. Yeah. They do that in action movies and stuff. Okay, so that's that one. That's the isosceles. No, it's not. It's C20. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. And you might also include there, okay, and the third side must be greater than the difference of the other two sides. Okay? So you might see an example like this. Let me just get a new sheet of paper. Say we have, you will see examples like this. Can 338 be the sides of a triangle? Who thinks yes? Who thinks no? Can I make a triangle out of those 3 pieces? Why not, James?
Because the two sides don't add to greater than.
Right. Because any 2 sides together have to add to bigger than the third side. So 3 plus 3 is 6. It won't reach, right? So if I were to, you could draw yourself a picture, right? Here's 8, here's 3, here's 3. It's not going to be able to reach, right? Okay? So you'll see some questions. How about 6? Uh-oh, the devil's coming. 6, 6, 6. Can those make sides of a triangle? Yeah, right? That what kind of triangle would that make? Equilateral. How about 3, 6, 6? 3, 6, 6. Can those make sides of a triangle? Yeah, right? Good. So what I always do, the easiest way to do this is just add those 2 together, make sure that sum is bigger than this. Add these 2 together, make sure that sum is bigger than this. Add these 2 together, and make sure that sum is bigger than that. Because sometimes it will work, like over here, 8 plus 3 is bigger than 3, right? And 3 plus 8 is bigger than 3. But 3 plus 3 is not bigger than 8, right? So that does not work. Okay, so no for this. So this is no, this is yes, and this is yes. All right. Next little thing we're going to explore. Okay, go back to your GeoGebra thing. This will be easy exploration to do. Okay, go back to your GeoGebra. Where's my GeoGebra? What is that? I don't know what happened. Oh, there it is. Okay, go. Don't cancel. I don't want to close my file. Okay, go back to your GeoGebra and make a new triangle. Let's get out of this. File, new sketch. File, new. I don't care about saving. Okay, so come on. Where's my new? There it is. Okay, so make yourself a triangle. Any kind of triangle you want. Okay? Try to make it so it's scalene. Okay? Scalene. I guess we should have labeled the points. Options, labeling, all new points, new points only. Sorry. Let's go back. Edit, undo. Let me try to make a triangle now and see if it labels the points. There we go. And measure all your sides and all your angles. Okay? So measure all the sides and measure all the angles. Remember that when you're measuring the angles, you have to go in clockwise order. Okay? So you're going to use this tool to measure the angle. Boom, 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 boom. Then measure the sides. Measure the sides. You could just click on them. And then drag them so you could maybe set your rounding. Maybe set your rounding to 1 decimal place, just for something different. Okay, there you go. And then I'm going to drag my angle measure so that I could actually see them. Okay. And I'm going to drag my lengths of my sides so that I could actually see them. Okay. Okay, so this is the next thing on your conjecture sheet. It's called the triangle. What's it called? It's called side angle inequality conjecture. If I look at my triangle, okay, where is the biggest? What is the biggest side of my triangle? In this triangle, or your triangle? Can anyone make a conjecture about the relationship between the biggest side and the biggest angle? Go ahead, Ryan.
They're opposite.
Very good. Okay, that's what, do you see that? That the biggest side of your triangle is opposite the biggest angle. It's kind of obvious, right? But it's true, right? Here's the biggest angle, here's the biggest side. Here's the smallest angle, here's the smallest side. You could drag your triangle around to make sure that it's always true. Now this is the biggest angle. There's the biggest side, right? Here's the smallest angle. There's the smallest side. There's the middle angle. There's the middle side. Can you drag that on your triangle to make sure that you understand how that works? Okay? So that's it's kind of obvious, but it's true. So that's conjecture C21. Okay, so I'm going to bring that up again. Okay, which says that's called the, what is it called? It's called the side angle, and I'll give you a couple good examples of that one. Okay, so side angle inequality conjecture, okay, says that in a triangle, if one side is longer than another side, then the angle opposite the longer side is longer than the angle opposite the shorter side. Pretty straightforward, right? But say I were to have a picture. Where's that nice tool that I have? The triangle freehand shape. This is my favorite tool. Freehand shape tool. So say I have this, okay? And I write in these angles. Say I know that this is 100 degrees. And say I know that this is 50 degrees. And say I know that this is side C, this is side B, and this is side A. And they say arrange sides A, B, and C from biggest to smallest. What would I have to do first? What would I have to do first? Ben.
Find what the other angle is.
Okay, and what is this angle?
It's 30.
That's 30. Everyone knows why that's 30? Right? Because they have to add to 180. So what's the biggest side of this triangle? B. What's the smallest side of this triangle? C. What's the middle side of this triangle? A. You get it? Is that easy enough? Easy enough? Okay. Straightforward. Got it. They do get trickier. I'm going to draw a trickier one up here. Say I have something that this is, I really like these tricky ones. This one's fun. Let's get a plain white sheet of paper. Okay, so let me get my freehand shape tool again. I should put that on my toolbar. Freehand shape. So say I have this diamond looking thing here. And then I have this going from here. Oh, it's the same color and everything. From here to here. And then I tell you that here's side A, here's side B, here's 70 degrees, there's 30 degrees, here is side C. I have two marks here. Here's side D, and this is 40 degrees, okay? And I say arrange A, B, C, and D. A, B, C, and D from biggest to smallest. Yes, green.
I think I can do it.
Okay.
I think B is the biggest.
B is the biggest. B is the biggest?
Yep.
What?
Is it? That's if that's 70, that's 30, then this would have to be 80. Oh, yeah. So B is the biggest of this triangle, right? So if I'm looking at triangle, we'll call it triangle 1 over here, right?
Yeah.
In triangle 1, it goes B, then what?
Then C.
Then C, then B, then C, then
D.
D,
Well, D's the same as C.
A, right? But D, is D the same as C?
D's 70.
Yeah.
D's 70 per second.
These both have to be what?
70.
70 and 70. So D is bigger than, D is bigger than, is bigger than A. But is D bigger than C?
No, it's the same.
D isn't bigger than C?
No.
No, it was 70.
You gotta be careful with that though, right? Because they're two different triangles, right? So you can't, in triangle 2, right? In triangle 2, which is bigger, C or D? In triangle 2, which is bigger? D, and then C, right? So it goes DC here, but C is the same. So D, do you know that D is necessarily bigger than B? Is D bigger than B? Well, it might be, it might not be, but you don't know for sure. You see? You understand why? Because they're two different triangles, right? So you know that D is definitely bigger than C. So D would have to go here. But as far as D is bigger than C, but you don't know, well, you don't know if D goes here or if D goes here, because B, even though it's opposite an 80-degree triangle, this might be a smaller triangle than this triangle over here. Yeah? No? Even though it might not look like it? Yeah? Okay, so it's kind of confusing. If I give you one on the test, this is kind of a bad example. It will be clear. Like this will be the biggest side of this. What I should have done is made this like 80, okay? Or something. That would have been easier to figure out, but it's not totally obvious what's going on with them. Okay? So you got to be careful with those. All right, moving on to the next thing. Let's get your GeoGebra. This will be a fun GeoGebra one. Okay? So let's go back to GeoGebra. Okay, you can use the same triangle you had. Was this a triangle? Where's a triangle? Is this? No, not that one. Where's the other one? This one? This one? This one. Okay? And what I'd like you to do is extend this side. Okay, so how do I do that? I am going to make a line go line, okay, make a line by going like this, boom, then make this line go through a point on the bottom of your triangle, kind of like that. Yes? No? You with me there? And then put another point on this line over here, okay? And then what I want you to do is measure this angle right here, BCD. Remember that you have to go clockwise, okay? So I'm going to measure the angle. I'm going to call it DCB, okay? So this angle has a measure of 81.4. 81, whoops, I'm trying to do this. Okay, and they call this, what is that symbol? I think that's a delta. That's alpha, this is gamma, this is beta, okay? So now what I want you to do, we're going to try to do this algebra thing again. This time I think I got it, okay? Go to View Algebra and make sure that you have your input bar, View Input Bar, and then go down here and type in some parentheses, okay? Shift, comma, and then add up, okay, this angle here, the two triangles in the two angles in your triangle that are furthest away from this outside angle over here. Okay, so add this angle here plus this angle here. So I'm going to do that. Remember the way you could do that, you could go alpha, and then you could just select angle. In this case, this is my gamma angle, so I'm going to click on the Y, and then I'm going to go plus, shift plus, and then I'm going to add to that angle this angle, which in my case is alpha. Okay, alpha, and then all I'm going to do is hit enter. Okay, and that comes out to be 81.4. Okay, can I drag that? Oh, look, I could drag it. Okay, 81.4. You could just drag it from right over there. Okay, and this is the sum of this angle plus that angle. Yeah, you with me? Were you guys able to do that? The two far away ones. Okay, so if this is your angle out here, add this one plus this one. Okay? And then drag your triangle around. Okay, whoops, I keep getting the wrong arrow. Drag your triangle around. Who can tell me something that they notice about this angle here, which is delta, and this angle here, or this sum, which is the sum of those two angles? Yes, Ben?
The same.
They're the same. Do you see that? Hello? This plus this is always going to be equal to this. Yeah? No matter where I draw it. Okay, watch. Where I drag my triangle, watch. 149, right? The sum of this angle plus this angle here, right? This plus this is also 149, right? So this is the sum of this plus this. Are you guys able to do that on your GeoGebra? You see that? You get it? I should have had you do it on a piece of paper, but it's fine, right? Questions about that? So that is conjecture. Who can tell me why that would be true? Anyone want to have any ideas why that's true? Say I call this, I'm going to try to write right on top of this, okay? Say here's angle A, here's angle B, here's angle C, and here's angle D. What do A plus B plus C have to add up to?
180.
180, right? What do C plus D have to add up to? 180, right? Therefore, what has to be true about A plus B plus C and C plus D? What has to be true about this quantity and this quantity? They're equal to each other, right? algebra, you could do a little substitution. So A plus B plus C equals C plus D. What's on both sides? What can I do with that C? Get rid of it. Okay? See that? A plus B is equal to D. Right? So what I just did, I did a little algebraic proof, right? Using that the sum of the angles of a triangle is 180, and this is called the linear pair equals 180, to show that these two angles, A and B, called the remote exterior angles, which is on your conjecture sheet, these two angles over here add up to this, okay? So looking at your conjecture sheet, C21, okay? C22, sorry. Triangle exterior angle conjecture. And this is an important one and a useful one too, okay? Says, it gives you, whoops, that's the wrong one, this one. Where is it? Triangle exterior, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote, what does it mean remote mean? If something is remote, what does that mean?
Like opposite, or far away.
Far away, okay? Far away. Far away. Right? If you go to a remote desert island, you go to a faraway island. The measures of the two remote interior angles. Okay? So you might want to draw a picture to remind yourself of what that means. Okay? Freehand shape again. I'm going to do this, this. Okay? Let's see. And I'm going to say that here's angle, we'll call this angle D. I shouldn't really, A, B, we'll call this point C. So angle, that's not a very good labeling of my angles. But angle A plus angle B has to equal angle D. Okay? And so say for instance I tell you that this angle over here is 110 degrees. And this angle over here is 57 degrees. And I say find the measure of angle B. How would I find the measure of angle B? Right? Just subtract 57 from 110, right? So measure of angle B is equal to 110 minus 57. What's that, 53? 53?
Yeah.
53 degrees, okay? So previously, what I would have had to do, it saves you some time, right? Because before I would have to say, well, this is 110, so that has to be 70, right? These have to add up to 180, and then I could find that, right? It saves you a couple steps, right? So instead of saying, okay, I know this has got to be 70, these add to 180, I could just say, well, I know that this plus this has to equal that, so that's how it works. Now, don't be confused. If I were to do this angle is also 110, but this angle is not, right? What's that angle right there? 70, right? So this is not an exterior angle. An exterior angle is the angle that is made by extending one of the sides, not the angle in between, okay? And so I'm going to give you one more example, and then we'll be done, okay? So say we had a picture that looks like, I don't like that paper. Let's find a picture that looks like freehand shape. There we go, okay? That looks like this, okay? And I say that this side over here is, that this angle is 3x minus 15. You have algebra, right? And this angle here is x plus 5. And this angle over here is x, okay? Find the measure of angle, let's label this correctly. A B, C of angle A, B, C. Who can tell me how to do that? Algebraically. Go ahead, George.
X plus 5 plus x equals 3x minus 15.
X plus 5 plus x equals 3x minus 15, right? Yeah. And then 2x plus 5 equals 3x minus 15. Then what? Then what? Evelyn, what do I do next?
You have to get all the numbers on one side.
Okay,
all the
so-
x's on
So
the
I'm
other
going to
side.
get, what should I get on which side? What do you think I should get on which side?
You could just minus the 2x.
Yeah, that's what I do. Take away 2x, take away 2x, right? So you get x minus 15 equals 5. So what's x equal to? X equals 20, right? And then, be careful, what's the measure of angle ABC? It's not 20, is it? What is it? 25, okay? That's all. Not too bad, right? Okay, your homework. Homework. Page 218. 1 through 17, all. They're not that bad. They go pretty quick. Okay?